Good evening and welcome to ICAR Academy. Myself Arun and I'll be handling your Deloitte classes in which we'll be talking about the frequently asked and most important questions which will help you to crack the exam. So let's not waste any more time and let's begin with the questions. Moving further, we'll begin with the most important principles. Let me share my screen. So we'll begin with the first question. Question states that given a list L of n numbers, which means you are given a list L which contains n number of numbers, what is it asking? Print this sum is of all checksums of elements of the list after eliminating minimum and maximum digits from the checksum. So what is it asking? He'll give you an array or list in which you have certain elements or numbers. From each number, you have to eliminate the maximum digit and the minimum digit. Eliminating these two digits, the remaining part you have to make the sum and print the final sum of the all numbers in the list. So that is the task. Let's move on to the further question. What is it asking for? A number should a number should be considered as zero. A number should be considered as zero if no digit remaining after eliminating the number. So make a note of this condition. What is it stating? Imagine suppose you have a three-digit number, 1, 2, and 3, let's say 200 or 321, in which you have three numbers, three digits, right? So you can eliminate a maximum digit and a minimum digit. But when it comes to a two-digit number, you only have two options, right? Only two numbers or two digits. So you need to eliminate one maximum and the other one being the minimum. So there is nothing else left for you to add the sum. So in these cases, you need to make it zero. Clear? It's given you certain instructions. Let's go through the instructions. What is asking for? Read the input from standard input and write the output to standard output. You should not write arbitrary strings while reading the input and while printing. Let me explain you how this arbitrary and standard input output functions work. He just states you that sometimes you will be writing functions like you will be taking input, right? Let's say x equals to end of input. A single number you will be taking an input. This is how you should take, but he's stating that no arbitrary strings or comments to be taken, which means that when you write this in the beginning days in your classes or labs, you would have observed, you'll say enter a number, enter a number. So you should not be mentioning any of such kind. This is prohibited. So that is what he states. Next, further, is asking us to take input from standard input, which is your input functions, which means that you should directly not take any arrays like this. He has told you that we'll be having a collection or a list which contains numbers, right? So no static or direct initialization allowed like this. Let's say 1, 2, 2, 4, 5, 71, 321. You should not take anything directly like this. Instead of taking like this, you should be taking this input, the list from the user. I'll also discuss about the question in more detail. Hold on for a minute. So what's next? We have few constraints where number n should be greater than 0 and it should be less than 10,000. And we also have some of the input formats. The first line of the input contains n, where n is the size of the list, which means it defines you how many numbers your list contains. Your second line states that the second line of input consists of n integers separated by single white space, which means you need to have knowledge on how to pass or how to take multiple inputs in a single line separated by space value. Do not worry if you do not know. I'll be telling you how to take it. And let's look at the output formats. A single line of output containing the sum of S, which means sum of all these numbers eliminating the minimum and maximum checksum. So let's look at some of the examples to get better clarity. I'll copy this array for you. You have this part. So before we begin, let me tell you three golden principles. So what are they? First one, you need to be clear regarding your problem statement, which means the question which is given to you. Each and every condition, each and every line should be clear to you. What is that? Problem statement. Problem statement must be clear, which means what is he asking for and what you should be printing, and not just how do we take it. It's also important how do we print it. Just taking it, you can take the same array or list line by line, but he's asking you to take all the elements of a list in a single line. So this is the clarity which you need to maintain while reading your question. He clearly mentioned, right? How did he say that? The first line containing n and your second line of input consists of n integers separated by white spaces, which means in a single line you must pass all the numbers in the list. We have a function to take that part. Let's move on to next question. So this is the clarity about problem statement. What to do, what format should be printed, and what format we should be taking the input. All the things which need to be clear comes under your problem statements. Once this is clear, next make sure that your code, you need to build the logic using few examples. I'll explain you the examples, do not worry. So you need to design your logic taking few examples and make sure that all inputs, your logic and code works for all given constraints, works on all constraints, all given conditions or constraints. Okay, so make sure that your variables which you are using are simple, clean, and clear. That gives you an additional advantage, because when you are in an examination center under pressure, you might forget to remember the variable names. So instead of just writing s as sum, you can take, this is quite feasible, no problem. The moment you see this variable name, you can clearly analyze that this is the sum of digits. So try to make the examination environment much friendly and much fearless for you. So these are the principles. Let's move on to the question directly now. It's stated that you will be given a list, which is this. So let me name my list. I'll name it AR, and I have the elements 1, 2, 2, and 3. 2, 3, and 4, and next we have 3,445, followed by 456. I'll take one particular number and explain you how this goes on. What is the first thing that he asked you? Your first line contains n, and your second line contains this part, your numbers. How will be taking? Using map function. So let me tell you some of the prerequisites which you need to know about this before we begin with this question. First, you need to have knowledge over lists, and next you also need to have knowledge over loops. We'll be using for each and while loop. So you need to have knowledge over lists, loops, and few of the arithmetic operators like modular division and followed by floor division. So why do we need to know all this? Once I go through the example, you'll be getting clarity why and where we'll be using all these concepts. So before we directly dive deep into this, you need to have knowledge over this. Okay, lists, loops, and few of the arithmetic operators. So let's begin with the question. What did he ask? In a given number, let's say if we have 1, 2, 1, 2, and 3, he stated that Eliminate the maximum and minimum digit in a given number. If this is a number, what are all the digits? You have 1, 2, 2, and 3. He asked you to eliminate maximum, which is this one, and the minimum, which is this. So after eliminating minimum and maximum, what do we have? 2 and 2, which results in 2 plus 2, followed by their sum will be 4. So for this, what is your final one? 4. And followed for this, you have eliminate the minimum and maximum. You will be getting 3 and eliminate. Let me take another pen, which makes it more clear for you. Eliminate the minimum and maximum. You have 8. Minimum, maximum elimination. You are left with 5. And finally, add these numbers. What are they? 4 plus 3 plus 8 plus 5. So this is what your final sum goes like, which should be 4 plus 3, 7, 15, and 5. 20 will be your final output. So what all did we do on this given one particular number? If you clearly observe, first we've taken a given number in the list. So how do we extract each and every number in a list? We have for loop. You can also use for each loop for convenience. Choice is yours. So in order to get each and every number, I'll be using a for loop. So list, already the question itself is list. And next we'll be using for each loop in order to extract each and every number in the list. Once this is done, what did we do? We split the given number. What did we do here? 1, 2, 2, and 3. We splitted this number into 1, 2, 2, and 3. So your next task is that you should be able to get each and every digit in this number. And how do we get it? There is a way. Let me get you back those old school days. I've given you 100 and I have 101. If I say 101 divided by 100, you'll say it'll be 1 point something. But what is the reminder if I ask you? You'll wait for a minute. Let me give you a small example. This representation is nothing but this, right? So 100 ones are 100, and final you will get a reminder 1. Now if you clearly observe, and let me also divide 101 again with 10 or any given number, let's say 1, 2, 3 divided by 10. Let's take this example now. Let's see the variations. 1, 2, and 3 division with 10. And 12 will give me 120, right? So my reminder will be 3. If you observe carefully, isn't your 3 the last digit in your number? If you observe carefully, the reminder which you've got is the last digit in your number. In this example of 123. So, and even though if you observe in this case, you'll get reminder 1, which is nothing but your last digit. So what is the logic? If you divide a given number with 10, then the reminder which you get will be the last digit. That is the first logic which you need to get. Clear? So what did we do? For a given number 1, 2, 2 followed by 3, if I perform modular division with 10, what will I get? I'll be getting last digit, which is 3. I'll show you once more, just a short span, 2 to 3, followed by, anyhow, you'll be getting this. And finally, you'll be getting 3 as the reminder. So I hope this part is clear for you. How did we get? So when it comes to modular, this is called modular division. When you perform modular division by 10 over a given number, what are we getting? The last digit in a given number. So since now you've known how to extract the last digit of a number, your next task, what I'll be doing is, I'll convert this number. I know how to find the last digit number, right? So what I'll do, if I can somehow make this number 1223 into 122, and this number, what is my last digit? 2, which is nothing but my third digit in the given number. So what we can do, if I can convert this number into 122, from this I can do modular division with 10 in order to get 2, right? So what I'll be doing, we have another arithmetic operator which is floor division. Floor division. Purpose, what does it do? Let me tell you the normal division first. Let's take, we have 1, 2, 2, 3 followed by 10. If I say this, what will be the final answer? 1222 point, as 1000 gets eliminated, it will be 122.3. This will be your answer. But the moment I say it is floor division with 10, your decimal part, which is over here, will be eliminated, which means your final answer will be 122. If you observe, isn't this what I want after converting the number? So I've got a function. I've got a way how I can transform my 1223 into 122. So what? I can perform floor division with 10 in order to get 122. Clear? So next what I'll be doing, I'll repeat the same process once again. I'll perform floor division on 122 with 10 in order to get, once we perform 122 floor division with 10, this is normal division which will result to you in 12.2. After converting into floor, this will be 12, right? So 12, and next on this I'll be performing same modular division. I'll get 2, this will be converted into 1. So once this part is moved ahead, what we can do, 12 will convert this on floor division with 10, transforms into 1, and then if I perform again modular division, I'll get answer 1. So we only have 1. Let me give you a note. What is it? If numerator is less than the denominator, and if you perform the modular division over it, your answer final result will be the numerator itself. When the numerator is less than the denominator, if you perform the modular division, your result will be the numerator itself. So once again, if I perform floor division on 1, look at this example, 1 on division with 10, what will be? 0.1. If I perform floor, it will be 0. After 0, if you perform any times floor division, it will still remain 0, right? So where do I stop? I can stop when it becomes 0. So what are all the steps I'm doing? I'm performing floor division and modular division in a repeated fashion. So you've already heard this concept, right? If you're performing a task multiple times in a repeated fashion, you can use loops for that, right? In the given session, for this problem, we cannot expect what sort of number, what the length of the number is, right? So when you cannot define how many times your loop has to run, in that situations you will be using while loop. If you already know how many times your loop should run, in those cases we'll be using for loop. Okay. If we take the first example, when we are talking about the list, here I know clearly that there are 4 elements in my list. So I'll be running my loop for 4 times. So in this case, you can take for loop, no problem. But when it comes to this example, when you're dealing with each and every number in the list, you cannot predefinely say that this number contains only 3 digits or 4 digits. So in this particular case, on performing a task repeated multiple number of times, we'll be using a loop. So which loop? As I do not know the length of the number which the user might give next, so I'll be using while loop to calculate. I'll be using while loop for what? And in while loop, what I'll be doing? I'll be performing floor division and modular division hand by hand. First, I'll be extracting 3, right? So first I'll be performing modular division followed by floor division, and I need to add this value 3, 2, 2, and 1. And your next task in the question states that till here, half of your task is done. In the given list, you've extracted the first number. From the first number, you have extracted each and every digit in that number. Now that you've known halfway, what is your next task? Eliminating the maximum and minimum number. So how do we do it? We have a function called max and min. You can use it, or you can also use the if condition, and I'll show you how to do both ways. Do not worry about it. So we need to eliminate maximum and minimum digit in the given number. After that, we need to perform sum of the remaining numbers, which is 2 plus 2, which will result in 4. So I hope you understood whole scheme. How we have performed this for one single number, you need to do it for each and every number in the list. So this is how it works. So meanwhile, when you are also calculating this part, simultaneously you need to define what is the maximum and also the minimums in order to eliminate. Once you get to know what is your maximum and minimum number in the list, in the given number, either you can ignore it using strings concept, or as we are currently dealing with only numbers, I'll tell you how to solve it in integer formats. So what I can do is, first I'll be calculating sum of all these numbers. Sum of all the digits means, let's say we have first got 3, which is maximum, no problem, I'll add it, then followed by 2, then followed by 2 plus 1. This is what I've got, right? So